students, for the session of database concepts and Oracle, and in today's session we shall discuss second chapter from unit 1, and the chapter name is database system concepts and architecture. Okay, so in the earlier chapter we have discussed the basic term. What do we mean by a DBMS or catalog or the different category of users, and the advantages of DBMS approach and the disadvantages we find in file approach and all, right? Fine. So in chapter 2, from chapter 2 we shall now concentrate the basic nature or the model, uh, what are the things that are accommodated in this database system. Okay, so as a index we are going to discuss these many things in this particular chapter. That is, the very first thing is data models, schemas and instances. We will be discussing the meaning of it. Then the very important frequently asked concept is three schema architecture and data independence. So with the diagram you will be given to explain this particular topic. And database languages and interfaces, the very important one. Which are the various database languages we find, and which are the different interfaces that are provided in the database environment for the users. Database system environment, how the environment in the database are there, how different models are considered. And the classification of database management system, like we have many varieties of DBMS software. So how, in what way it is classified, these things will be discussed in this particular chapter. Okay, so as a first discussion we shall discuss with the data models. Okay, fine. I hope all of you are observing the current term data abstraction. This we have done with the first chapter. What is data abstraction? That is trying to highlight only the essential data for the user. Or data abstraction, it normally refers to the suppression of details of data organization and storage. That is, with the low level details like we are not bothered of like how the computers are actually converting the high level data to binary data, or how that binary data again will be converted back to high level language. So these are what some low level details, or the background that happens, or the stage of processing happens at the computer. So the any users who is using the computer should not be given much burden to understand those low level details. According to his work, what are his requirements, at a very easier what steps, with the minimum time, with the minimum inputs, he should uh, get done with the task with the help of a computer. So data abstraction means we are hiding the details of low level data, and only giving the user the essential ones, like how much is necessary to finish up his task. Okay, that is a meaning. If you just go much detail about it, observe here, it refers the suppression. Suppression means what? You're avoiding, you're hiding the details of data organization and storage. How the data are stored. For example, student file. I mean, if I'm a DBMS user, in the college I'm using some student database. I'm trying to save the student information. I'm not bothered how the designers or the programmers have defined the student file background. Are you all understanding? So how it is being stored and all. And the highlighting of the essential features for an improved understanding of data. So the background definition, or the structure, how the data are defined, how it is being stored, all these are what? Some low level details. These detailed information we are hiding in data abstraction, and we are highlighting which one? Only the required features for a user to perform his task. That is the meaning of a data abstraction. Okay, one of the main characteristics of the database approach is to support data abstraction so that different users can perceive data at their preferred level of detail. So the thing here is, the main intention in the DBMS environment or in the DBMS software is they try to give the data, store the data with the concept of data abstraction. What is that? Trying to avoid making understand the different users with many low level details, like unnecessary information, like how each file is being defined, how it which are the restrictions that are given. Many such data are not what required at the front end with the users who are using the database. So keeping in mind the category of users or the different users who are using the DBMS software, in how much simple way the information has to be what displayed for them, or the details how much has to be given them. In that way the data abstraction is considered in DBMS environment. Okay, so uh, now understand, after understanding data abstraction, let us now move to the exact definition of a data model. What is it? A collection of concepts that can be used to describe the structure of a database, provides the necessary means to achieve this data abstraction. So data model here is like, for example, if an institution is introducing a database, domain, student, course, many such things. So which are how much ever the concepts they want to store or what information they want to store. That model, the collection of concepts that can be used to describe the structure of a database. For example, so they have decided to store the course information. They have decided to store the student information. So student, course, student, about a student, what has to be stored, how the data has to be stored, what are the constraints, restrictions that has to be put while saving the data about a student. So this is what you mean by a model. Okay, a collection of concepts that can be used to describe the structure of a database, which is going to provide the necessary means to achieve this abstraction. So uh, storing the low level details separately, and providing only the required details at the user and with the help of a query processing, we refer as which one? Data model. So in a more simplest way it has to be told means, data model is going to help which one? The data abstraction. So it is what? The collection of concepts, like maintaining the catalog, or defining the information in a student file, or about a course file, about a grade report file. So the collection of concepts which can be used to describe the structure, like how the student file, the structure of a student file has to be saved, has to be defined. All such concepts, collective concepts of storing a particular structure of data, is referred as a data model. Okay, and by structure of a database we mean the data types, the relationship and constraints that apply to the data. So that's what I told. If you are defining a student database file means, like in the student file which are the data types we are defining to store the, to hold the student data, and what relationship the student table is having with another one. For example, the student table is having the relation with the grade report table, right? And the constraints, what is that constraint? Like student name should be of character type only, student number or roll number should be a unique key, primary key. I mean the data what you are entering there should be unique to each other. Okay, so these are what the constraints you are applying. So by structure of a database means we mean the data types, relationships and the constraints which is going to be applied on to that data. And most data models also include a set of basic operations for specifying retrievals and updates on the database. So what we would like to uh, tell here is, many data models normally in the database environment, they include a set of operations. Which are those operations? Particularly to add the information, to retrieve the information, to delete, to modify the information that are present in the database. Okay, so data models not only define the structure of a database, but also they include a set of basic operations for specifying any retrievals and updates to that database. Okay, so remember this. Then you have certain categories of data model. So let us know which are those categories of data model. High level or conceptual data models we call as what? High level or conceptual data model, which provide concepts that are close to the way many users perceive data. So like for example, when we are using some programming like the C++ program or the C programming, these are what the high level programming languages, and when you are executing these programs you are giving the input, and your input is of which type? The input is in a language in which the user is aware of, and we are aware of the English language, the standard language which is used to interact with the computer. So that is what the high level language. And high level or conceptual data models, here the by name itself, it provides concepts that are close to the way many users perceive data. So how we perceive data in the real world, in the mini world. So according to the user perception, how we find the data, how the things are viewed by the users in the DBMS environment, such views are referred as high level or conceptual data model, whereas low level or physical data models provide concepts that describe the details of how data is stored on the computer storage media, typically magnetic disk. So I already told, like, we are not always bothered with the low level details, like how the computer is going to process our input at the background, how it is going to store the information. These are what something the processing happens at the low level. I mean, this is not essential for the user to be aware of in order to use any application. So in the data model, we have two categories. One is which one? Conceptual data model, and another one is physical data model. Conceptual data model always refers to the high level data, like how the users perceive the data, the which one? Database concepts, whereas the low level or the physical data model refers to which type of concepts, like how the data are defined in the DBMS environment, how it is stored in the devices, storage devices. It all encompasses that. Okay, so remember this. It may be asked for 2 marks. Define the categories of data model. One is conceptual data model, and another one is which one? Physical data model. Another way is high level data model and low level data model. Okay, then concepts provided by low level data models are generally meant for computer specialists, not for the end users. Who are end users? For example, in the institution, we staffs are actually accessing the student data. So office staff also are accessing the student data. So we are the end users, and we are not normally not bothered with the low level data. We are bothered with only with the which one? High level data. So who are actually in exactly accessing the low level data models? They are the which one? Computer specialists or the designers or the programmers. Okay, between these two extremes is a class of representational data model. So between these two means what? We are speaking high level data model, low level data model. So in between these two, high level and low level, we have one more level that is referred as, in between to both of them, we are having one more model referred as representational data model or implementation data model. So what does this do? Which provides concepts that may be easily understood by end users but that are not too far removed from the way data is organized in computer storage. So a representation model is something like the middle level between the high level and low level, and what they say is the representational model or the implementational data model helps the users to understand actually how the informations are organized, stored at the low level data model. Are you all understanding? So at the most there will be the data model, representational data model will be giving an idea for the user to understand how the informations or data are structured and stored at the low level data. Is that clear? Then, representational data models hide many details of data storage on disk but can be implemented on a computer system directly. So, in this representational data model, they are not defining in detail how the data are stored in the secondary storage devices, how the data are stored on the disk, but um, they can be defined, or they can define the implementation, how the data are stored on the disk, uh, in which one, the computer system directly, how the data can be stored in the system directly. That implementation level they can easily represent. Okay, so with this particular slide we come across how many model? Three models. One is high level model, representational model, and low level model. Okay, so high level is also referred as conceptual data model, and the second level is which one? Representational or implementation data model, and third one is which one? Low level or physical data model. Okay, so physical level or physical data model normally represents the information like how the data is in the database environment, how the data are stored in the Dbms environment, normally in the disk and all. And the high level details are what? Normally it represents the concepts which the users are aware of, or how the users view the information in the database environment. According to the user perspective, the concepts are provided in high level data model, whereas representational data model tries to define the user how the informations or concepts are stored at the low level data model. Okay, so this is about the categories of data model. Still, we have certain points. Conceptual data models use concepts such as entities, attributes, and relationships. So this you have to remember, students. Normally, the high-level data model, like it tries to store the concepts according to the user's perspective. I'm frequently telling this one. So when the model is trying to store the information in such a way, then what are the concepts it is implementing? So the very important one which you should remember is entities, attributes, and relationships. So entities and attributes again you will be come acrossing in C++ also, whereas data abstractions also, you I think you will be finding the definition there with the object oriented features. Whereas here, in common to that C++, what you are learning, the terms, entities, attributes, and new term is relationship. This is very important in database concepts. Okay, so always remember you will be asked with these basic definitions, even if you uh, come to the stage of developing a software in your sixth semester. You will be asked with these basic questions. What do you mean by an entity, attributes, and relationship? Okay, so let us define one by one. An entity represents a real world object or a concept, such as an employee or a project from the mini world that is described in the database. See, whichever the concepts we users, we people have created, we have implemented in our real world, those things are referred as entity. For example, we mean what a person means. Person means what? A human being with certain characteristics. Which are the characteristics or attributes I can tell? A human being will be having a name, gender, some date of birth, contact information, like this. So a person can be called as a entity. And employee. Employee is what? We are in real world, we have a meaning of an employee. Any person who is working under an organization, who is being employed by one particular person or employee. So employee is an entity. Similarly, a student, a person who is getting the education, those person or human being is referred as a student. These are all what? Some real world representing things. Are you all understanding? So an entity which is representing the real world. In the real world, these things exist. There is an existence of a student, employee, person. We have something like bank. Okay, so these are all referred as an entity. So any real world object or concepts. For example, employee, project. Project means we have project number. That project is handled by which department. Okay, many said that, so like that. Project name, project members. So these are certain attributes of a project. Okay, now let us go with the second term. What is an attribute? Just now I spoke about an entity. Employee is an entity, student is an entity, project is an entity. So each entity will be having its characteristics or attributes. So what is that? An attribute represents some property of interest that further describes an entity, such as the employee's name or salary. So anything that is going to define the property or characteristics of an entity is referred as a attribute. So employee name is an attribute. Employee is having a salary, it is an attribute. Employee date of join, these are all what the we refer as a attributes. Okay, and relationship. So a relationship among two or more entities represents an association among the entities. For example, a works on relationship between an employee and a project. So for example, before I take this employee and project, in our first chapter we have discussed course and grade report. Sorry, student and grade report. So there is a relationship between which file, which entity, student entity to grade report. Are you all understanding? So there is a relation between student and a grade report. Similarly, in a organization, employees will be working, and there will be that company or organization will be working on certain projects. So that projects are handled by whom? By that organization employees, right? So project means project members are there. Which employees? Project members are nothing but the employees. So which employees are working on that particular project? So there is a relationship between an employee and a project. Okay, so in the company domain we have a entity called as employee project, and we have a relationship between the employee and the project entity in among these two entities. Okay, so that is what you mean by relationship. A relationship among two or more entities are represents an association and connection among the entities. So for example, work on relationship. So employee and project is having relationship. Which type of relationship? That any employee working in an organization will be working on one or the other project. So an employee works on an project. Are you all understanding? So that is what they refer as work on relationship between an employee and a project. Okay, so I hope you have understood about the concept or the meaning of a data model, the then categories of data model, and this under this particularly with the conceptual data model, the basic terms like entities, attributes, and relationships are the very important one, most frequently asked in 2-mark questions. Okay, so with this discussion, with the second chapter in the first unit, I'll conclude my today's session, and let's discuss more in our next coming sessions. Thank you all.